So chapter 9, we're going to talk about what's going on inside the atom. Chapters 7 and 8 had a lot of math in them. Chapter 9 is much lower in math, but it is high in some weird ideas, so be warned. You guys heard of the Hindenburg? It's a picture of it. 1937, they made this airship, dirigible, flew it across the ocean. They got across the ocean, but as they were landing, it burst into flames. It was filled with hydrogen. I don't know who thought hydrogen was a good idea. It's flammable. Now they still make blimps. They advertise over football games and stuff. But they fill them with helium instead, because helium doesn't burn. So the question that we're going to ask is, what makes hydrogen so reactive and flammable? Why does hydrogen do that, but helium doesn't? What's different about them? Modern blimps are filled with helium. I'm pretty sure they photoshopped that. Introductory chemistry, right? Or maybe that's just a drawing. They fill them with helium. Why is helium inert? Why doesn't helium burn? What is it about them that makes them so different? So we're going to learn about models that explain why helium is inert and why hydrogen is reactive. Are other elements as reactive as hydrogen? Yes, there are other elements that are as reactive. The group 1 elements are very reactive. Lithium and sodium are metals, but they react very violently with water. They give off hydrogen gas and so much energy that they ignite the hydrogen gas, and so you get an explosion. Helium is in group 8, the periodic table, with the noble gases. And the other noble gases are also very inert. And so there are these patterns in the periodic table, and we're going to look into why those patterns exist. We mentioned the idea of models and theories way back at the beginning of the semester. And models and theories help us explain what we observe. Okay, there are laws that say this is what happens. We're looking now into why does it happen. So we'll talk about some models and some theories. The Bohr model is one model that is important, and that was one of the first ones. And the currently accepted one is the quantum mechanical model. And both of these propose explanations for the behavior of elements and for the periodic law. And if you've forgotten, the periodic law states that when elements are arranged in order of increasing atomic number, certain sets of properties recur periodically. These models help to explain how electrons exist in the atoms and how those electrons affect the chemical and physical properties of the elements. And I'll give you a little foreshadowing maybe. We're going to find that the periodic law has to do with the electrons. And the reason that we see these patterns in the periodic table has to do with patterns in the electrons. These are some great quotes. Bless you. Niels Bohr developed the Bohr model of the atom. And he was still around when the quantum mechanical model came about. And Schrodinger and Einstein were both involved with the quantum mechanical model. And Niels Bohr said, anyone who is not shocked by quantum mechanics has not understood it. Erwin Schrodinger said, I don't like it, the quantum mechanical model, and I'm sorry I ever had anything to do with it. Albert Einstein's reaction was, God does not play dice with the universe. The quantum mechanical model is really kind of mind-blowing. Not really, it is mind-blowing. I mean, here, Einstein, these are really intelligent men, very learned scientists, and they were bothered and disturbed by the quantum mechanical model. It is just very hard to think about, but we're going to go there. We'll boldly tread. The quantum mechanical model is foundational to understanding modern chemistry. It's the basis of our modern periodic table. It guides our understanding of chemical bonding. Why do hydrogen and oxygen bond together to make water? And quantum mechanics also helps with applications like semiconductors, which are involved in computing, and this incredible technology that we have in our pockets, in our cell phones. I mean, this is science fiction, right? From not very long ago, this was complete science fiction. How can we make things that small? Well, it's through an understanding of what the atoms are doing and what the electrons in the atoms are doing. The design of new drugs. Quantum mechanics helps us to find new drugs much faster than the old trial and error method.